Okay, so now we're going to turn our attention to systems of inequalities. So I'm sure you can guess that these are going to be very similar to systems of equations, except now instead of having equations, we have inequalities. So the goal of this section is to graph systems of inequality and indicate the appropriate region of the solution through shading. So the reason why, if you notice here, what are we doing? We're saying, look, we're going to solve this system of inequalities through shading, right? So if I'm going to be shading a region, why is it that we prefer to do this graphically? Is because if we try to solve this algebraically, we're going to notice that there's infinitely many points, or there's a range of values. So usually when we're solving systems of inequalities, one common method used, or a method that's actually beneficial to us, is to do this through graphing. So so before we get into actually solving this, what we're going to do is we will first begin by graphing inequalities. So what I'm saying is we won't start off by systems. First we'll say, okay, look, if I give you an inequality, how would we show what that inequality looks like visually? Okay, so once we do that, once we learn how to graph inequalities just by themselves, then we will apply them to systems. So what you'll notice is, hey, if I could graph an inequality, then applying it to a system is not difficult, right? There's just one minor change to it, okay? So before we do that, let's kind of talk about the steps. So when graphing an inequality, we will follow these steps. Okay, so the steps that we're going to be following are two steps, and they're pretty straightforward. So what's going to happen is we're going to start off by saying, well, graph the equation that's related to the inequality. So what I'm basically saying is, if I gave you an inequality and you look at that inequality, and if you change the inequality to an equation or an equal sign, you'd notice that, hey, the graph of that is something that you've seen in the past, or they're very easy to see. So then how does the inequality change things? So then we'll turn our attention to the inequality. So if the inequality is less than or equal to or greater than or equal to, the graph is solid. Okay, so that means we have a solid graph. We would say that if the inequality is less than 2 or greater than 2, notice how this doesn't have the equal sign, then the graph is dashed. Now the reason why we're saying if it's dashed here is because how come? If it's less than or greater than, what is it saying? It's not equal to the graph. So that's why it's dashed. So we're saying, look, that's kind of like our border, but the border is not included. Over here, the equal sign, the reason why it's solid is we're saying, look, we'll also take that as a part of our solution. So anything that lands on the graph is a part of the solution because of the equal. So that's kind of like the main difference. So once we graph them, then the next part comes in the shading portion. So we're going to say shade the appropriate region based on the inequality. So you'll see that once we do an example, it'll be kind of obvious as to which region we're going to be shading, okay? Now, what if you have a problem where you're like, well, I'm not sure which region to shade? Well, that's not difficult. Then we could figure out a method of how we would shade, what region we would shade. So what I'm basically saying is the following. If you're not sure which region to shade, then plug in a point to test to see if it makes the inequality true or false. So basically, what am I saying here? We pick any point, and the point that you want to pick, you want to make sure it doesn't land on the curve. Okay, so as long as it's not on the graph, pick any point, plug it into your inequality. And if your inequality is true, you'll notice that, or that point will either make your inequality a true statement or a false statement. So here's how we know which region to shade. If true, then that's the region to be shaded. So what does that mean? Your curve is going to break up your region into two parts, for instance. So if I pick a point on one side and my inequality is true, then that means that's the side I'll shade. Now, what if it's false? So if false, then what does that mean? That's not the region you should be shading. Then you should shade the other region. So then the other region should be shaded. Okay, so with that said, let's look at an example where we will graph a couple of inequalities, and you'll see how that works. Okay, so for our first example, we're going to say graph each inequality. All right, so for part A, it's x squared plus y squared is less than 81. So if you look at this, see, if I ignore the inequality and I said x squared plus y squared equals 81, you should recognize this as, so let's put in parentheses equal sign. I'm not saying it's equal, it's really less than, but if it was equal, you'd notice that, hey, wait a minute, this is the equation of what? A circle centered at the origin with a radius of 9. So what is this saying? My graph that I'm going to draw here is a circle, so let's actually do that. So and it's centered where at the origin, and my radius is 9. So I'll say 9, negative 9, 9, negative 9. And what do I know when I graph this? Now the question is the graph of this solid or shaded? Now notice, since it's less than, remember, if it's not less than or equal to, it has to be shaded, or dashed, I mean, not shaded. So since this is less than, it's going to be a dashed. So it's a circle. And what do you notice this circle did? This circle broke up this plane into two parts. There's the inside of the circle and the outside of the circle. So what is it that we want? This inequality is saying I want everything that's x squared plus y squared, which is less than 81, which less than, if you were to guess, it would be what? The inside, right? Because the less than means I want everything less than this circle. So if this is the circle, to be less than it, I'll go, the shaded region should be the inside, okay? So let's pretend you weren't sure about this. So we can choose a test point also. So as long as I pick a point that's not on the circle, and usually when the origin is available, I always choose the origin. So if I pick 0, 0, if I plug it into this inequality, If I get a true statement, then that means I should shade. So notice, what are the two parts? It's either inside or outside. So if I plug in 0, 0 here, then I get a true inequality. What does that mean? I should shade the inside. If I plug in 0, 0 and I get an inequality that's not true, then that means I shouldn't shade the inside and I should shade the outside. So look, if x and y are both 0, if I plug it in here, 0 squared is 0 plus 0 squared is 0. The left side is 0 less than 81. Now the question is 0 less than 81? So the test point was what? 0, 0. If 0 is less than 81, which it is, that is in fact true, what does that mean? I should shade the inside of the circle. So that's my solution, right? So my solution is all the points, and see, this is where we could see why we have infinitely many solutions, because it's all the points inside of the circle. Now, how many points are there inside the circle? There's infinitely many. So the shaded region pretty much gives us our solution. So that's our solution, the shaded region, okay? Now, a second example would be something like this. X plus 4y is greater than or equal to 9. And if you look at this, we know that this is a line, right? If I change this to equal to, the graph of this would be a line because it's a linear equation. And then since it's also greater than or equal to, the equal to is saying my line should be solid. So to graph this line, the easiest thing to do is what? Is just to, you could either write it in slope-intercept form if you want. So you can grab that and say, look, if I solve for y, what do I get? Y is equal to negative 1/4 x plus 9/4, right? And so I only took the equal because I'm trying to graph this. So what is it that we know here? Our graph looks something like this. So 9/4 is what? Is 2 1/4. And then what is it saying? My slope is negative 1/4. So go down 1/4 to the right. So it's something like this, right? So I'm just going to sketch a general sketch of it. Okay. Now, obviously, you could have graphed this line in various ways, right? I just chose to write it in slope-intercept form. We don't have to. Maybe it would have been better if we just found the x and y intercepts and went from there. But anyway, now we need to figure out, well, which side do we shade? Well, look at what this is saying. This line breaks this up into two parts. There's everything above the graph, the line, or below the line. Now, look, if it's x plus 4y is greater than or equal to 9, if we were to guess, our guess would be what? We should shade everything above the line, which that's the case. So our answer is what? It's just everything, everything above this line, right? So once again, if you wanted to check, if I use the origin as a test point and I plugged in 0, 0, what would I get? Plug in 0 for x, plug in 0 for y, you get 0 is greater than or equal to 9. Now, what do you notice about that? Is 0 greater than or equal to 9? Absolutely not. So since I picked this point and I plugged it in here and I got a contradicting answer, because 0 is definitely not greater than 9, what does that mean? I shouldn't shade below the line, I should shade above. So just so you know, if you're ever not sure about, hey, how do I know which region to shade? You can just plug in test values and you'll go from there. But most of the time it's pretty straightforward. We have a pretty good idea, okay? So moving on. So now that we know how to graph inequalities, let's talk about systems of inequalities. So for systems of inequalities, we're going to basically say when solving systems of inequalities, we will graph each inequality on the same coordinate plane and once we graph them, and obviously we will shade the appropriate regions, so and shade the appropriate region. Okay, once we do that, once all regions are shaded, the solution then becomes the region where all shadings overlap. So I know I didn't talk about, hey, what are a system of inequalities? I think you guys already know that, right? It's two or more inequalities. It's that are considered at the same time. So if I have two or more inequalities, that's considered a system of inequalities. But the key here is what? We're going to graph each inequality and shade their appropriate regions. And then since it's a system of inequalities, my solution means what? I want the region where all of the inequalities kind of capture. Okay, so once I shade all the regions for each inequality, then my attention is going to turn into, well, where do all of my shadings overlap? And the place where all your shadings overlap, that's your solution of your system of inequality. So technically speaking, it's kind of like we're doing the same thing we did in example 1, except now we're going to be graphing multiple inequalities on the same the coordinate plane. Okay, so let's look at our second example, which we'll do 3 of these, 3 different systems of inequalities, and then we'll hopefully you'll have a good idea as to how this works. So graph the solution set of the system and specify its vertices. So let's not worry about specifying the vertices yet. Let's just graph the solution set of the system of inequalities. So my first system of inequalities is just literally x squared plus y squared is less than 25. And then the next one is x plus 3y is greater than or equal to 5. Okay, so what we're going to do now is we're going to go step by step. So for this one, notice how this system is just composed of 2 inequalities. So let's look at the first inequality. So the first inequality is what? X squared plus y squared is less than 25, which we know that this is what? A circle centered at the origin with a radius of 5. So and we know that this circle is dashed. How come? Because it's less than 25. Now, since it's less than, the region we're going to shade is inside the circle. Now, here's where we have to be careful in how we shade things, or it doesn't really matter. You could use different colors to be able to see where they overlap. But for the circle, I shaded diagonally going towards the left. So for the line, when I shade it, I'm going to shade it diagonally going towards the right, downwards to the right, just so it'll be easier for me to see the overlap, okay? So for the x plus 3y is greater than or equal to 5, that we know is going to be what? That's going to be a line. So if I were to use the, the x and y intercepts to find the x-intercept of this, what do I need to do? Set y equal to 0, and if y is 0, x is 5, and then if I set x equal to 0, which would give me the y-intercept, my y-intercept is 5/3, which would be somewhere right there. Okay, so if I were to graph this line, it looks something like that. Okay, so then what do we have? It's greater than or equal to 5, which if it's greater than, that means we would shade above. So if I shade above the line, I get something like this. Now, hopefully you could easily see where the overlap is. Where is the overlap between these two curves? This is my overlap. All right, so my solution is actually that region. Now, obviously, this upper half, which is dashed, that's not included, but the lower half, the lower part, since it's solid, is included. So that the region of my solution is right here because that's where they overlap. Okay. Now, as far as the vertices go, the vertices are literally just find the points where these systems intersect one another. So there's that one, which that one we already know, right? Because that's the x-intercept, which is at 5, 0. Now this other vertice we need to find, but what is that vertice? It's literally what? The point of intersection between these two guys. So if I want to find a point of intersection, what is it that we're really doing here? I'm just grabbing x squared plus y squared equals to 25. Now see, I'm getting rid of the inequality because I care about where they meet each other, which now I could turn this into a system. This turns into kind of like what we did last section. So, and then what's the other one? X plus 3y equals to 5. So what am I doing now? I'm solving for the system, which will tell me the points in which they intersect each other, which is literally our vertices. Okay, so I could use substitution. So what do I know here? If I take this one and solve for x, I get x is 5 minus 3y. And if I go back and replace x up here with 5 minus 3y, what do I get? I get 5 minus 3y squared plus y squared equals to 25. And this will give me the y values of their points of intersection. So if I square this out, what do I get? I get 25 minus 30y plus 9y squared plus y squared equals to 25. And then I'm going to be solving this. It looks like by factoring, right? So what would I get here? I would get 10y squared minus 30y. If I bring the 25 over, no, actually they cancel out, which is nice. So equals to 0. And if I factor out a 10y, what do I get? I get y minus 3. So what do I notice? The first y value is what? Y equals to 0, which makes sense because that one has a y value of 0, which I already know that point. So the second one I care for, which is up there, that's this guy, which is what? Y equals to 3. So if y is 3, then I could come back up here and substitute it in there. What happens if I plug in 3 for y? I get 5 minus 9, which x becomes negative 4. So that point is negative 4 comma 3. So just remember, if you're asked to find the vertices, you're just finding the points in which the curves that create the solution are intersecting one another. Okay, so that's basically part A. Now let's go on to part B, which would be a different system. So part B is x plus 5y is less than or equal to 15. X plus y is less than or equal to 11. X is greater than or equal to 0. Y is greater than or equal to 0. Okay, so now let's actually solve out this system and see what we get. So once again, what are these graphs? The first one, that's a line again. So if I find the x and y intercepts, what do I get? If I set x equal to 0, y is 3. So if I graph that, I'll get that. And then if I set y equal to 0, x is 15. So let's call that 15. So what do I know? This is going to be a solid line. So it's going to go that way. And since it's less than or equal to, since it's less than, well, the equal makes it solid. The less than means shade under it. Okay, and then what do we have? Then we have x plus y is less than or equal to 11. So what is it that we know? This has x. So if x is 0, y is 11. So it'll be somewhere up there. And then if y is 0, x is 11, which puts us somewhere here. So this is once again going to be a solid graph. So for this one, since that one I shaded going downwards or upwards from left to right, this one I'll go the other way. So I'm going to shade everything below it. So I'm going to go this way. Okay, so now we could see where is the overlap. And by the way, for this guy I'm shading under it because it's less than or equal to. So we could see the overlap is where do these curves crisscross? So far it's down here. And then what else do we want? This is saying x is greater than or equal to 0. Well, x equals 0, that's a vertical line, which is what? The y-axis, isn't it? So that's x equals 0. And if it's greater than, which way? And let me actually use a different color. So if x is greater than or equal to 0, that means shade everything to the right. which what do we know so far? What's happening? The region that I want is this guy. And then lastly, what is it that we have? Y is greater than or equal to 0, which y equals 0 is a horizontal line. And if it's greater than or equal to 0, it's what? It's everything above. So it's everything is here. So if you look at this, where is the region where they all intersect? And if you notice that the region where they all intersect is actually, see, maybe we're better off using different colors, but that's the region where all four curves overlap. So my solution is literally just that region, okay? So just keep in mind that whenever I'm graphing these, I want to make sure that I capture all of the regions in which they kind of, they all overlap, okay? So these are the two examples that I actually wanted to go over to make sure that we understand. Now, like I said, maybe you're better off using different colors for these guys. It'll be easier to see where they all overlap, because sometimes, especially if you have large systems, it might be a little complicated to see where the region is where they all overlap. But once you figure out all the overlapping regions, then you know exactly what your solution is, right? So for this one, we needed to find the parts where all four of them overlapped, okay? So I hope this was good enough. Just remember, you're mainly going to be dealing with curves that you've dealt with. It's either going to be circles, lines, and so on, and even maybe parabolas as well. But the shading is the region. The shaded regions is what we care about here, okay? Now, and by the way, for this one other comment I want to make is what? These borders, which are all solid, those are also a part of my solution. So I will take the borders. Only the dashed parts are not a part of our solution. Okay, so just keep in mind that the borders are a part of the solutions, and so is the shaded region inside. Okay, so this takes care of the systems of inequalities. Please, once again, do not hesitate to reach out to me if you have any questions.